Good evening. I'm Karen Tucker, CEO of the Churchill Club. Welcome. Our program tonight is called Is Software-Defined Networking the Next Networking Revolution? We thank our program partner, Ericsson, for not only working with us to form the panel, but also for opening their doors to us this evening. Let's give them a hand. Very generous. Thank you. We are privileged to have with us a remarkable group of speakers tonight. Najam Ahmad from Facebook, Martine Casado from Nasira VMware, Erik Ekudden from Ericsson, Matt Palmer from SDNCentral, and of course our moderator, Craig Matsumoto from Light Reading. Welcome and thank all of you for being here tonight. A brief introduction for our new guests in the audience. Churchill Club is Silicon Valley's independent business and tech forum and has been convening unique Silicon Valley style gatherings for candid conversations, such as the one that we are going to participate in this evening, for over 27 years. What drives us every day is to encourage innovation, economic growth, and societal benefit. And we do this through the up to 40 programs that we present each year where like minds can learn and connect with one another. Please remember that the reason that we are holding this event in the first place is for you, the audience. So if you feel that the speakers missed something that you think is important, it is your responsibility to participate in the audience Q&A. Ask for the microphone and bring up the topic, please. And one more thing, we are a member-supported nonprofit organization, and if you would like to become a member of the Churchill Club tonight, simply stop by the registration table and we will sign you up for $99, which is $26 off the normal membership price, and voila, you will be a proud member of this great organization. Our next program will be held on February 7th as we present LiveOps Chairman Maynard Webb and CEO of eBay, John Donahoe, discussing a new era for work. It's somewhat of a leadership conversation, very forward-looking. This is in San Jose at eBay. And on February 11, we present Building Trust in 2013 with Richard Edelman, CEO of Edelman, Eric Channing Brown, who's the GM of Integrated Communications at Skype, and Jeffrey Pfeffer, who's a well-known author and Stanford professor. Peter Burrows of Bloomberg Businessweek will lead that conversation at the Computer History Museum in Mountain View. So we hope you'll join us for these two dynamic programs. If you're tweeting, please do use the hashtag Churchill Club. And you'll find other Twitter codes in your printed program tonight. Let me now introduce our conversation leader. Craig Matsumoto is a product of Silicon Valley, having grown up here. His mom actually worked for Apple and his dad worked for IBM, so covered a lot of territory there, I'm sure, in dinner conversations. He was an engineering manager. He studied engineering in college, and he moved to journalism after that. And after a long stint covering electronics and networking for EE Times, 7 years or so, just over 10 years ago, he joined Light Reading. And he's presently the North America managing editor there, and he covers, among other things, the topic of our conversation tonight. So please do give your warmest Churchill Club welcome to Craig Matsumoto.
Okay, thanks, Karen, and thanks everybody for coming out. We're hoping to give you a really good discussion here. So as Karen mentioned, I'm with Light Reading. We turned 13 years old in February. We're an online news site covering networking and that sort of thing. So I've gotten into SDN through the routing and switching beat. I took that over from Maggie Reardon back around 2004. Started hearing about OpenFlow a couple years ago, and from that got into the whole SDN discussion. So as Karen was saying, the topic is SDN the next revolution? You've all heard the term SDN. You've heard a lot of the hype. I'm sure that's why you're here. And so many of you probably work in something you would consider SDN. So our goal here is to hopefully provide you with something a little bit more than you've heard in the last 6 or 7 SDN panels that you've gone to. We're going to try not to tread over the same old ground and look a little bit towards the scope and impact of SDN, what it really means and how it's really going to affect the industry and us as people in the industry. So I'm going to let each of the panelists introduce themselves down the line here. We'll start with Najam.
Sure. I'm Najam Ahmad. I'm part of the networking team at Facebook. So my team worries about all connectivity between machines within the Facebook environments and connectivity to the end users, which are spread all over the world. So we're really trying to figure out how to deliver an experience to the users around the globe.
Martin?
Okay, so I'm Martin Casado. Sorry. I was the CTO and co-founder of Nicira. I'm now at VMware, and my title there is Chief Architect Networking. And I've been involved in kind of SDN OpenFlow for, quite a while.
Erik?
Yes, so I'm Erik Ekudden, and I'm head of technology strategy for the Ericsson Group. I'm also CTO of the Silicon Valley organization here for Ericsson. And this is where we have our IP and broadband headquarters for Ericsson. It's also where we do a lot of our SDN research and working with partners in the valley.
And I'm Matt Palmer. And previous to SDNCentral, I'm probably the accidental SDN person here, which was about 18 months ago. We started to just figure out if we started to tweet #SDN and #OpenFlow, would anybody follow us? And by doing that accident, we got thrown into SDN, and now we have a large community that's really the user voice of SDN.
So you're saying you didn't actually know anything about OpenFlow, you just wanted to put hashtags into like...
That's pretty much it, was to see if people would think you'd be a thought leader for doing that, and,
Excellent.
And we did. So
apparently you are.
So we've been learning on the job.
All right, so to start with, I don't want to get into some 25-minute semantic discussion about what SDN does or doesn't mean and what should or shouldn't be included in it, but I think we should start with a little bit of a definition just to frame the conversation. And since we have Martin here, who has been there since the beginning, or since the beginning of this phase of what we're calling SDN, I thought to start off with you, Martin. What did SDN used to mean, and how does that contrast with what we're talking about now?
Okay, sure. So I'll give you a very brief history lesson. So SDN, the term was actually coined in 2009 by Kate Green, and she was doing an MIT Tech Review article on, now SDN as an acronym has been around forever, and the term software-defined networking has been used in various forms I've heard forever, but like this current instantiation came from an MIT Tech Review article on OpenFlow in 2009 by Kate Green. And it's because Nick, Scott, and I, who had been doing the OpenFlow work that the article was on, are horribly uncreative when it comes to naming. And so she says, well, what's the name for this? And we're like, eh. And she's like, well, I just did software-defined radio, so how about software-defined networking? We're like, that's great. So that's the original name that we use now. And at the time, there were kind of two academic contributions that they came out of. And these two academic contributions are for people who build systems, not people who buy systems, right? I mean, we're doing research for system builders. And the two contributions were, we thought that it would be better if networks allowed more innovation, and so we wanted more general hardware. So instead of fixing algorithms and hardware, we wanted it to be more like x86, more of a set of primitives, and then more functionality could be in software. That was innovation one. Innovation two was, we thought that today, the networking architecture kind of dictates how you write your software. Now, it hasn't always been the case, but like the standard way of doing it. And that makes it difficult to build certain types of systems. So we thought if we decoupled the software from the distribution of the forwarding elements, we could kind of choose how we wanted to write our software. And you could provide kind of tighter guarantees for certain types of things. So the goal was for system implementers, if you wanted to build systems, you would use these two practices if they were useful, and we could prove things that you couldn't prove before. And that was the origin.
Okay. Okay. Now a lot of other things seem to be kind of included in SDN. Actually, Matt, you're probably well versed in this too. You probably run into this too. Anything related to virtualization, to network management, tends to kind of get put in the same bucket. How do you feel about that? Because I have let people use a pretty broad definition of SDN around me, and the reason is because I think all these things are related. I think they're all going to kind of answer the same questions. Do you have the same sense?
I do. I tend to think of SDN in terms of enabling people to do something they couldn't do before. And I like to simplify that into really sort of three primitives. One is simplification. of how you actually implement networking. And simplification means that you can scale and reach a new scale that you could never have before. And that kind of leads to the second one that we start to define as around automation, which, you can use the word virtualization or orchestration, but we tend to use the word of automation because that's what drives this notion of how can I really scale a network that has to handle 10x, 100x, 1000x traffic in sort of this mobile, social, and cloud world that we live in today than what we had to live in 5 years ago. And then the third aspect to that is assurance. How can you find a way through software to assure that you can have the same primitives that you have within the hardware to actually make the network operate the way that it should?
Okay, and then like I said, so I think all of these things are kind of related enough that we can include them in the discussion. I don't want to get too hung up on what should or shouldn't count as SDN. Although if you don't like the way we're using the term, you can come at us during the Q&A and call us out on it. So let's talk about a little bit about what this accomplishes. Najam, when we talk about these possibilities for automation or from freeing ourselves of the network architectures, what does that mean to you? How do you intend to use any of this, or are you using any of it now?
So for us, it's primarily the pace of innovation. Or the ability to do things as much like we do in all part of the stack. So if you look at Facebook architecture, we own the stack from the kernel on the server to most of the time the client or what's client software running. And we're able to iterate very, very quickly on things that we want to try. So we build stuff, we deploy it, and we iterate over and over again, and we're able to do it on a day's notice, overnight at times. The only piece of the stack that we can't do this on is a network. The pace of innovation is fundamentally very, very different. Anything that you want to do is a 6 to 9 month cycle to get a product feature built that you can go deploy in the environment. So for us, the primary thing is, can we build an environment where we can actually do the same thing as we do it across the stack, where we can try different things, adapt to traffic flows, adapt to failures, adapt to how the application's evolving, and iterate over it again and again. And the networking, the vertical nature of vertically integrated nature of networking technologies today just does not allow us to do that. So the way we think about SDN is the fundamental block, as Martin described, the two principles that it started with, is giving us the agility to be able to go build new things, new technologies, new features, and still have a forwarding plane that actually can pass the bits.
Okay.
And then we can control it using software as we like. We have a bunch of use cases that we are thinking about and we're working on today, but there are lots of use cases we haven't thought about yet, and we will over time. And that's the idea, is that we can build a platform, if you will, that will allow us to build those use cases as they come along.
Okay.
And that's the fundamental for us for SDN.
Well, what kind of time frame are you talking about for these use cases? Is this stuff you think you'll do tomorrow or 10 years from now?
We're building stuff today, right? So I'll give you a simple example. If you think about an end user and how that end user gets to a machine on the inside a Facebook data center. You have DNS doing a bunch of routing in terms of geolocation on where a user is, routing it to the right POP. From there you have BGP taking the traffic to the data center. Then you have load balancing technology that actually picks the server that the user connection ends up on, all sorts of things like that. So you have several different policies or mechanisms that are sort of disjointed. And we don't really have more of a central view of what that process or what that policy looks like, and how do we adapt to things when there are failures, right? For example, Hurricane Sandy happened, New York POP goes away, power went out, how should the network behave? So network took the network down, great, but their application's still running on top. What's the mechanism to be able to actually deal with that kind of scenario in a very graceful manner, adapt to traffic patterns, adapt to load, and move traffic and users around in that sense. Okay. So that's a use case that we're building on right now, and doing prototypes to do that.
Okay, but what kind of time frame are you thinking of for some of these use cases? I mean, are these things you want to be able to do in a year, or do you think that
We want to do things now.
Well, okay, you want to do it all now.
So,
you want to do everything right now, but
yeah.
realistically, how much time are you budgeting? Like, how much do you expect to wait before you can really implement some of this stuff?
So as I said, I mean, for us, this is something that we're trying to build in a way that our infrastructure is built to allow this to keep going on forever, that we can keep iterating, keep building new use cases.
Okay.
Right? So it's fundamentally taking the network infrastructure and building it in a way that allows that innovation to happen over and over again. And we're starting with 1 or 2 use cases to start proving it and start actually building that infrastructure that will allow us to do that going forward.
Okay. Okay. And so, how about the other panelists? Are you seeing the use cases people are dreaming up broadening for SDN as the idea has been out there? And how soon do you think some of these things can become reality? Like when will we start seeing effects of SDN being present in people's lives?
Yeah. Well, maybe I should give it a try and then hand over here. I think that what we are seeing is, when we talk to our customers, service providers, they are really looking at how SDN could change the network, the bigger network. So not only the limited data center or perhaps other limited applications, so the wide area network. And in the wide area network, of course, things doesn't happen overnight. We all know that. But on the other hand, there are some very compelling features that SDN brings, and I think we've talked about a few of them here. When we talk about service provider SDN, for these wide area networks, we add yet another set of features, including common control across from everything out in the smartphones, base stations, all the way up to the data center. We include common management across, and we include this service exposure part. That's really where we see this wide area network usage. And I think that some of the use cases we already have in today's network is just that they are not made in an efficient way today. So you could talk about traffic engineering, you could talk about setting up sessions faster, more rapid provisioning, so you get all the flexibility.
So you're saying they're doing things that we could count as SDN if only they were more SDN-like?
Well, what I'm saying is that this is how we see the use of SDN technology in the wide area networks. And I think your question is really, when do we start to see that these use cases will be used by users or sort of real networks? And then my answer would be that some of these use cases we will start to see being implemented commercially this and next year. So it's not about a 5-year project to get it out into the wide area network. Okay. And these use cases, I think, I agree with some of the use cases that were brought up, but there are also some very fundamental use cases about, as I said, traffic engineering, how to route traffic between different appliances, how to do things more efficiently at the IP edge. So if that is part of your question, when will we see it implemented in these networks? And it's coming along.
You think it's pretty soon?
It's coming along, piece by piece, but not across the whole network.
Well, what are you saying, Matt? I mean, some of the stuff will start coming out this year, you think, maybe? Get put into use this year?
I would sort of separate out, I'd separate out the enterprise and the service provider.
Okay, yeah.
And I think there's 2 pieces to that. What we're finding is that the people who look to implement SDN this year, and very similar to Najim, are folks that are looking for a competitive advantage that they can use to grow their business. They're not looking to wrangle out costs. They're not looking to sort of save a couple of dollars here. They're not looking to add another 5 or 10 million in revenue. They're looking to really transform their business. And those folks today, they already have POCs going. And they're very similar to Facebook and to Google. They're writing their own applications, and they're finding the experts to help them go write those. The rest of the community, what we see is we see a lot of budgets happening and opening up for trials and POCs. But the number one inhibitor that we see, and this will be primarily on the enterprise side, is the lack of security. So where we're seeing these get stopped is the security guy going, guess what? This is not as secure as my physical infrastructure, and I get fired if I can't prove that. So guess what? We're not doing SDN in production. Service provider's a little different, but we still hear the same security concerns.
Okay, I was going to say service provider is different because they don't care about security, but
I think it's different because they have a little bit more control of the overall infrastructure, and they can deploy it for a point solution a little differently than the enterprise.
Okay, great. But service providers, they run into the problems of scale, right? They're talking about a whole different scale. I mean, wouldn't that be an impediment to, or I would imagine that they would do everything a lot later than the enterprise would.
Well, I think I should not speak for all the service providers, absolutely not. But what we are seeing is really that if you look at those use cases that are confined to one domain, or maybe looking to change part of your network, then that can actually be done also in the wide area network. So I think it's actually coming along also on the service provider side. Yes, it's happening in the enterprise, it's happening in the data center. We hear a lot about it, but we are also seeing that there is momentum now building up on the service provider side. So I'm very hopeful. But I mean, just stressing the point that I tried to make earlier. I mean, when you look at the basic technology, you have the virtualization, you have the split of control and forwarding. If you want to take that truly to a wide area network, then you need to combine it for all the domains. You need to do it across anything from access, transport, up to the edge, maybe part of your policy control and services, and then into the data center.
It's a much bigger problem. Exactly. You've got these different zones of a service provider network that are enterprise.
Absolutely. But that's also where the benefit comes. That's really where you can get all the gains.
I think the other thing to add to Eric that we see is that this notion of that the enterprise and the service provider being different is also we're seeing them blending. And so when I mentioned those use cases before, I meant the traditional enterprise use case, meaning, you know, if I'm a bank, how do I segregate all my traffic and do my things? We're working with clients that are financial, large retail, large consumer good companies. So think Fortune 50, Fortune 100.
Okay.
They're looking at, we've got one in particular that says, I have to build a members reward program. And that thing is going to be as big as Facebook if we're successful someday. Now, they won't do all the cool stuff that you do, but their goal, and they realize that their infrastructure has to look increasingly like a service provider, or as a cloud service provider, which is, you know, arguably maybe something that Facebook might be considered.
Okay. So some of the stuff starts appearing pretty soon, maybe late this year.
For kind of an alternate view.
Sure.
Yeah. So, I mean, I think what's difficult about this conversation, of course, is like sometimes SDN means networks that don't suck, and then everybody argues that networks suck, right? And so, like, you kind of have to be fairly clear. So let's say that SDN is a model where you can have networks that are horizontally integrated, which is a lot of the original decision. So you can get your networking from whoever you want, right? Traditional vendor A, or off of some ship from Taiwan, or wherever you want. And then the functionality is provided by a software layer, wherever that software layer is. And it allows you to do things or solve business problems that people don't solve today. So I'm just going to use that. So if that is the definition, and I would argue that there's been production deployments of this stuff for years, and like large production deployments of these things. Like, for example, I worked on the first 2 controllers. I helped build, I think, the largest controller that's ever been built. And we have networks that have been in production for, that support easily tens of thousands of hosts.
Okay, and when was that? How long ago?
Well, I'm trying to think of the original deployments, but certainly these have been over a year that these have been deployed. Okay. And again, I don't think it actually makes, I think it's possible to break down between like the different verticals, but like when it comes to early adopters, like people buy because they want to, like independent of kind of what segment. So like certainly, we have customers in the enterprise space, and we have customers in the service provider space, and we have customers in the government space. And so I've found like early adopters don't really map so much to like the different market segments. So I think, to be fair, like there are notions of SDN, which is like maybe I'm going to get this and implement my own networking logic, and I'm not sure that will ever happen. But there are other notions based on, I think most people would agree, are SDN that have been used in practice for a while. So I think that it really is a reality now.
Okay. Okay, I can see that. And well, and to one of your points, about the early adopters, the impression I've gotten is that while we do see a lot of use cases out there for SDN, that the bulk of the customers are still kind of indifferent to it. Or that's what I've been hearing on the enterprise side, especially, where there might not be as much immediate benefit. I'm talking about normal enterprise, not giant cloud kind of enterprise. So it might be starting now, but it's kind of small right now, isn't it?
To say something, so I've probably in the last 4 months done 150 customer visits. Like I'm 80% on the road, right? So that's all I do these days, right? So, and in my experience, if you go and you're like, listen, I've got SDN, I'm going to pull it out, like it's part of the sales engagement, like, hi, Mr., whoever I'm talking with, I've got SDN, and they're like, this is great, and then we're all excited. You talk about all the benefits, and they're like, okay, what am I going to do? And like, well, you can do security and this and that and the other thing, and it's normally the same list that we've had for the last 5 years, and people really can't map this to a business problem.
Okay.
Where if you have a product and you're like, I've got product X and it solves business Y, whatever that is, it could be many things, like time to provisioning goes down is a big one, or or the ability to lower operational overhead, or the ability to lower capex, or inter-data center issues. I mean, things that there are products today, then of course that their sales cycles all over the place. And I do think this is an early adopter curve, but I wouldn't say it's because of size or because of vertical. It's normally because there's someone in the account that like hasn't been there for a long time and wants to make a name for themselves, or because they actually feel the pain, or because they're cool, or whatever. But I mean, I just think that this is a lot of sales dynamic going on that we're way, way ahead of like this early adopter. Like we're out of the academic research papers. We're certainly out of the people going to the users groups, and we're into like, actually having business discussions. And I mean, depending on how you count it, there's thousands of this stuff deployed today. I just don't think it's like, people aren't going in and saying, I have SDN. They're saying, I've got product X, which uses a lot of these things under the covers.
Okay, well, and a lot of the things that say it can do there are things, like you said, that people have been asking for a while, or wished for a while. So in that case, it kind of, I guess, becomes an easier sale, an easier discussion. So I want to get to the revolution part of our title, because when OpenFlow first came out, not when it first came out, but when word started getting around, 2009, 2010, I think everybody's first reaction when they heard OpenFlow was this, oh, this is the end of Cisco. This is what Cisco can do. We're going to put it in a software box somewhere, and that's the end of Cisco. And then the conversation has broadened out from that considerably. So what kind of scope are we talking about with SDN? So we've established that we've got these little tricks we can do to do things like speed up provisioning times, to be able to change the network more quickly and more on the fly. How much of the network do we want to do this with? I mean, does SDN, as we're talking about today, eventually become the definition of networking in 10, 20 years, or is it just going to be a little niche thing in certain parts of certain networks?
Better become the thing. At least that's what we're pushing for in that sense. The days of vertical integration are, I think, gone, and the industry has to adopt. The vendors will adopt as well, which you see all vendors are trying to adopt to that as well. So it's fundamentally a different way of building networks or solving network problems per se. So I think that happens, it's inevitable that the entire network stack will become this. It's the old paradigm. I think if you listen to Nick or Scott Schenker, they have presentations around how this relates to the early days of computers, where you bought a box from IBM, the chipset was IBM, the hardware, the OS, everything was part of that, and that's what you bought, and it did what it did, and when you needed something, you went to IBM to get that particular feature. That doesn't apply. That's how network has been working, and that's how networks work today. I wouldn't go to an HP and say, buy a server and say, yes, I don't know what the processor is and I don't know what the operating system is, but yes, it's a great server. You'll just never buy that. But that's what we do in the network space today, right? That's where we go buy a box that is the operating system, and oftentimes we don't really even have a good feel of what that operating system is and can do. And we have the CLI interface and a bunch of protocol sets to be able to figure out how to system integrate it. So it's fundamentally a system integration shop, the networking technology set, right? So most network shops are system integration shops. It needs to move out of that into more of a, as Facebook considered itself, a software company. And we need to be able to write software to be able to solve our problems, right? And that's where the network technology set has to go.
Erik looks insulted.
No, I think this is exactly the right. No, this is exactly the right thing, because it is a big change. It is absolutely a big change in the networks, and more so on the fixed side. Of course, many of the things that have happened in the enterprise and the fixed side of the network, they need this type of simpler architecture and this type of more rapid introduction of services and everything that we talk about here. So I think it's absolutely a big change in the industry over the coming years. But I think it's also good to reflect on the fact that, yes, we do have the mobile side, which is growing, especially here in North America and around the world, which is really where people attach. So when they connect to that enterprise or that cloud, they do it from smartphones. It's 1 billion smartphones today. It's going to be 4 billion in 5 years. So it's completely dominating attachment to these clouds and these networks. So the mobile part will affect what we do in the network so much more than it has ever done until now. And many of the things that we now talk about in SDN, they are actually already there in the mobile side. They have been implemented in various forms over the years. Now we're changing a little bit the architecture and the protocols, and we're reusing much of that when we move it into the fixed network. And when you think about that everything is going to be mobile, everything is going to be mobilely connected, then of course the network has to change. They have to be adhering to this principle of programmability, of flexibility, of scalability. On the mobile side, we already have scalability to hundreds of millions of sessions, of devices, of users. Nothing as like that has been heard of in the fixed side. So of course, it's a big change on the fixed side. Absolutely.
Okay. I can kind of see that, because on the mobile side, you have the ability to independent of location, have one person connect to another one to create that connection immediately, tear down the connection immediately. I can kind of see that.
And we have to then patch that mobile user all the way to a server or on a data center somewhere, because that's if they're trying to get to Facebook. We want to look at the end-to-end from the handset to the user and the entire experience.
That's true. You care about what the network is doing.
Exactly.
All those places.
We care about the whole thing. And I would also like to add, though, is where if you build this fundamental technology set and the way of building networks, doesn't mean that every network user will be able to actually do it. There are still a lot of enterprises which will not have the software capabilities to actually go build it. So vendors still have that space to come up with the value proposition, and that's what the use cases are about, where they can build use cases that all the enterprises would want to use.
Okay.
Right? But companies like Facebook would want to build it ourselves.
Okay.
In some sense.
Hold that thought for a second. But Matt, you had something you wanted to...
Yeah, I have a different view on what's going to sort of be revolutionized or what's going to be transformed, which I agree with all the other panelists, but I think there's another angle to this, which is really the human element to it. So we spent a lot of time interviewing folks, and when I had my startup in the cloud networking space, one of the things that we learned was that there's a major generational shift and change happening in not just in compute, but specifically in networking, which is that the folks who built the last or the current generation of networks were really CLI folks. They're scripting, they're CLIs. This next generation of folks, they're used to web interfaces, REST APIs, and they're used to programming a network just like they'd program anything else. So I think it's really more of an evolution of skill set and a generational change in terms of the people who are going to build these networks to solve the next generation of problems.
That's interesting. You don't think the old generation will just force the new generation to learn CLI because it's cooler?
I don't think they can. I don't think they can. I mean, I'll give you an example.
Actually, let me give you, this may be kind of a weak counterexample, but the counter-argument would be, you look at a Bloomberg terminal. It doesn't use any of the new mouse or pointy things that you've got. It's all text. And the reason is because people have gotten to the point where they can do the text stuff without thinking. Right now, we have networks that are kind of controlled by the people who know the CLI, right? That's sort of the magic cult you get introduced into in order to control the network.
The point is not that it's controlled by the CLI. The point is it's controlled by people. We want to have it controlled by software.
Okay.
Right?
Yeah.
So we want to have people writing software that then controls the network. Like often people ask me, hey, where's your NOC? I'm like, don't have one. Hey, when are you going to build one? I'm not going to build one. What do you mean you're not going to have a NOC for a network? Well, we're not. Why? Because we want to have software to actually deal with what happens in the environment. So our NOC is we want to have people writing software that deals with the incidences that happen automatically, right? Or through software.
Okay.
That's the fundamental difference.
Okay.
That's a good point.
Yeah.
Do you mind if I say something
Sure.
quick? So I think
Sure.
I think in this discourse, there's this logical leap that we all make and we've been making for like 5 years, which I'm starting to think isn't true, which is so, like early on, like I was responsible for a lot of these papers, we'd say, well, okay, we've got this network topology, and then we kind of centralize stuff, and therefore it's easier to program, right? And a lot of people say, SDN makes it easier to program, and now like the masses can program these networks, right? You can use Python and this and that, right?
Yeah.
So it turns out, I think that's a lie. I actually, seriously, so I actually don't believe you've reduced any complexity. So again, having worked on 3 of these systems and having, deployed them, which is, you end up, taking these brains. So every switch has a brain. You take these brains, you make like one big brain or a few smaller brains, but these brains still have to deal with every link event, every change event. And so like, it's kind of funny. So I've worked on a layer that sits above. So you work on this central control that's supposed to be easy, right? And then, ergo, you've got like very simple programming. The reality is to actually make the job of a developer easier, like reduce topology and hide complexity in the way that's useful. Okay. In our experience, is probably the difference between 2 man-years and 50 man-years. Which is there's an awful lot of kind of logical leaps we're making where you're saying SDN, ergo simple programming, right? Where you should say SDN allows you to build a system, perhaps, maybe you can use SDN, maybe you can use another mechanism that's actually going to hide complexity, that's actually going to make someone's job easier because it's hiding some details of the network or some details of what's going on. And SDN says nothing about that, right? All it says is it's in a different place. It doesn't say anything about reducing complexity. And so it's kind of nice, like Scott, Scott gave the talk before me where he was like, protocols and abstractions, and he's one of my co-advisors, protocols and abstractions, therefore things are easier. Like the reality is it's not easier unless you can actually create those abstractions, and creating those requires a tremendous amount of work. And so I think the next level of at least self-realization and honesty is going to be realizing that we've done nothing but kind of like we woke up in the morning, we're like, oh, there's a bump on the bed, and instead of actually trying to like remove the bump on the bed, we've just kind of been moving it around. Like we move it close to the pillow, we're like, oh, the bump looks close to the pillow. Like it's like time to get rid of the bump, and like that's work. And we haven't, a lot of us haven't done that work yet, and I think that's going to be like a next big step.
Yeah, you've kind of moved the problem to a skill set that's more fun to you, the programming side as opposed to the CLI. Yeah, I see it. Well,
you do get a lot of flexibility though, so if you add those layers that I think you have come to realize that you need, be it common control or that OSS or management layer on top that really simplifies things, then on top of that, of course, you can expose things to make it easier for developers. It's not down at the SDN controller. You're absolutely right about that. This is a layered approach where first fix the networking piece, make it really working together, so not isolated domains, isolated islands, make it connected across from the smartphone all the way to the cloud, and then on top of that open up from the OSS upwards to developers. I think you're spot on. This is exactly what needs to be done.
Okay, so what do we do to get there? Because it sounds like the SDN conversation hasn't really focused on that yet, and I agree with what Martin said, and I like Najan's point about a lot of this being about automation. So we want to automate and abstract the network. We want to take the work out of running the network in a sense, let it do more stuff on its own. Do you see SDN, how well do you see SDN addressing that right now? Matt, Erik, I mean, is there anybody looking in that direction?
Well, I certainly should give you, but I think that we apparently are not completely agreeing what the industry has evolved to when it comes to what really SDN needs to encompass. And I think this notion of what we call the service provider SDN, that really covers some of the things that we talk about now. It really covers the next step, because that's what you encounter when you go outside the box. Breaking up a router into a control and forwarding thing, that's in a way a simple thing. When you take it to multiple domains that needs to interconnect, and probably all the way from the data center through all of these network nodes all the way down to the smartphones, then you're exactly solving this problem that needs to be solved. You need to connect the things in order to abstract them. So I think we are on our way to redefine SDN in a very good way. We're using the components and we're adding layers on top. That's our view.
Okay. Matt, any thoughts?
Yeah, my sense today is that I think we as an industry are overestimating where the customer really is and where the use case and the problem really are. Meaning, back to what we see is we see every deployment be custom developed, custom put together, custom integrated with everybody's solution. So I fully agree with Martin's statement that there's anywhere between an extra 10 or 50 man-years just to get this to happen. But getting back to the voice of the customer around how do I get competitive advantage, and how do I do something? The SDN's not for the faint of heart. So what we see the customers doing today. So maybe sort of pull that back. 6 months ago on SDNCentral, what we saw was everybody asked, well, what is it? What is it? What is it?
Yeah.
Today we're getting asked the questions of, well, how does it get done? And what could it actually do? And now we're getting asked for, well, could somebody show us how this happens? So, my sense is that we still have a good 12 to 24 months for folks, for mainstream folks, not the early folks, to say, hey, I can make this leap and I can take it forward.
Okay. What that something occurs to me then about the nature of the equipment vendors as they stand today. Because if we want so much of this stuff to become that much easier, it almost sounds like we're asking them to work themselves out of jobs, in a sense. Or do they become more like service? Erik doesn't agree, but this kind of touches. I'm deliberately avoiding the question of whether Cisco gets completely commoditized, because I think we all agree it's not going to happen, or at least not going to happen anytime soon. That's become kind of a trope of these discussions. But I am wondering if we really want to help end users get this more abstracted, more automated network, what does the role of the systems vendor become then? Are they maybe the integrator who helps you put all that together, or shows you how to program it?
So I see this role, and I see it morphing over time. Today, that role is what we see as the smart vendors are ones that are looking at this and going to their customers and saying, hey, guess what? We're not here to sell you a box or sell you some bits. We're here to make a co-investment with you to solve a real problem, and we need you to put up some cash, and we're going to put up some cash. That's today, and that's what we view as that's probably the next 12 to 18 months. After that, what we start to see is prepackaged software showing up that will require more of sort of a true integration, sort of SI opportunity to tie that together and to actually then get that deployed into a network. But again, we're 18, 24 months out before folks are actually really there, just based on what we see of the SDN products. And then what we also see is that 24 to 36 months out is when the prepackaged products are actually deployable and they're mainstream, and you see this really broad adoption in the enterprises and the service providers, which is also part of the reason why we look at this and go, boy, it would be great if we're an SDN startup with a lot of money, but boy, it's pretty darn scary if we're an SDN startup with a lot of money, because those next rounds of financing are going to be pretty tough. That's our view.
Yeah, okay.
I think that there is, it's good that you bring up this SI thing, which is of course needed, but I think that one thing that we haven't talked much about is really the basic performance of the network, and that will still, especially we talk about big wide area networks, service provider networks, the performance and the stability of those networks is extremely important. So we have to safeguard that, and that does not, even though we have to sort of get away from the box thinking and how to build new protocols inside a box or between two boxes in one domain, we have to go towards connecting domains and connecting boxes across. When we're doing that, it's still so that to get good performance, you need a very close coordination or connection between the hardware piece and the software and control piece. Otherwise, you cannot guarantee the performance. So I think there is absolutely a role for very, very solid performance in the hardware piece, and a little bit more flexibility in the control, because you can move functions around, you can get the flexibility, but they still need to be very linked together. There's no way to guarantee performance otherwise.
Okay, does that imply that you are better off buying an entire quote-unquote framework from one vendor under SDN? I mean, does this lead you?
I think this has to evolve over time, because today we have multiple domains, and they need to continue to sort of work together and coexist with a multi-vendor situation. There's no question about that. But I think if you want to realize the benefits across domains, of course, controllers need to start to talk to each other in a way that they haven't done before. Okay. So that needs to happen. Yeah. Okay. There has to be a level of interoperability there that. Or sort of linking controllers that are in different domains, whether it's in one vendor or multiple vendors. Yeah. Okay. Martin, did you add something?
So, yeah. Like this whole issue about the incumbents, I think, is either tautological or it's kind of sloppy thinking, which is like if we start at the highest.
A lot of both, yeah. No, I agree.
Right. So like if we start at the highest level, okay, what is SDN? Networks that don't suck. Okay, all right, that's good. We all want that, and in that thing, like vendors or new entrants can do that. So okay, let's drill down a little bit more. Okay, so what else is SDN? So it's not just that networks that don't suck. It's like networks that don't suck, and they allow for innovation, and they scale, and they do things that we like. Well, clearly, again. The vendors can play and new entrants can play, right? But then people like to tack on. They like to tack on this definition, and it's it's open or it's horizontally integrated. Well, then by definition, you're like somehow creating this new definition which says that it puts pressure on the vendors, but it's almost tautological. What I don't see is that there's a logical connection between these three characteristics and that last one that people like to tack on. Okay. So I just think we're being very sloppy with our words here. We're saying, well, I like all this flexible, great stuff, and therefore, ergo, you're going to get, you're going to have this independence, which is it's not clear at all to me that this is the case.
Okay. Okay, fair enough. No, I think
So
you're
I guess
right.
bottom line,
And,
if you define it to mean that it's going to put pressure on them, then clearly it will put pressure on them. But I don't think there's anything natural in the problem statement that would.
okay.
I would agree with Martine. I think to add to that,
Yeah, I would too. I've been guilty of that kind of sloppy thinking myself, so I agree. Yeah.
we see two fallacies that we continually hear, sort of myths around SDN. One is that there's this notion, the hardware vendors are going to be commoditized, and myth number one is all these switches and routers, they're all made at the exact same space by the exact same contract manufacturer, and those who buy the most volume get the biggest discount. So at the end of the day, if Cisco or Ericsson or somebody really wants to win a deal, they can out-discount anybody else to win it when it comes to the networking hardware side of the equation.
Okay. Yeah.
The other fallacy that we see, and we see propagated a lot, is open's great, open's wonderful, open's going to save the world, we no longer have vendor lock-in. And that notion is also pretty darn silly, particularly as we look at it from an SDN standpoint, because the open source software in SDN is almost exclusively, each and every one of them is almost exclusively controlled by one vendor. When you look at open source, you go, well, I'm buying into an ecosystem, and maybe that's the right ecosystem. It may solve a real problem for real customers, so that's good. But believing the notion that it's actually open source and it's flexible and anybody can take it, we're not dealing with a Linux or we're not dealing with Apache Foundation type code here. We're dealing with other type of things that have vendor interest tied to them.
Okay. Okay. Martine, you and I talked a little bit, kind of along the lines of what happens to the vendors, about the future of the physical network versus the virtual network.
Yeah.
Where the physical network is the network we're accustomed to, the virtual network is kind of growing in importance. And I think you were saying you saw at least the forwarding state in that virtual network still being the purview of routers.
Yeah.
Which would
So I think
but
this is
the other side.
Yeah, so I think this is a really interesting macro level trend to talk to, and I think actually Najam is the right guy to talk to this. But if you just sit back and you forget kind of what we learned over the last 4 years, and what are the macro level trends? What you see a lot are these mega data centers with really awesome architects. That the physical forwarding, of course, it doesn't go away. You need to have high port density. High port density is best done with specialized hardware, for sure, right? But you have these physical networks that provide interconnected bandwidth of tens of thousands of servers, and then everything else is done in software at the edge somewhere. Distributed compute harness, the load balancer, x86. So if you look at any of these big web farms that are doing, they're effectively cannibalizing IT and the app space, the way that they're building their data centers have very, very simplified, not simplified from a Gates perspective, but much less pressure on the physical hardware, and the intelligence is in software. So it has the same properties we talk about, but what's very interesting, and I actually want to tie it back to what you said, and then I'll shut up and let Najam talk, which is, if you assume the physical hardware is just going to be passing packets, and you assume the only thing that's required to have is IP connectivity, for example, the only requirement that you have on the hardware is a very solid, very slow-moving interface that probably hasn't changed in 10 years, right? So as opposed to having some very complex fat interface like OpenFlow, which I wrote the first draft a long time ago, which it's kind of very difficult to kind of maintain this because this is evolving and this is evolving. If you're saying at a macro trend, you've got these big data centers, you've got this simplified hardware, and the software at the edge is just using it only to provide connectivity, right? Mm-hmm. Now roles are starting to separate, which a lot of the functionality, things like security, things like isolation, things like load balancing, things like packet replication and multicasting are often being done at the edge in these software places while the hardware is just providing the capacity. I think it's a very interesting trend that we should all be watching. And I think Najam is actually one of the foremost experts to talk about this. So.
Well, I don't know about expert, but that's the fundamental problem we have. We have very large-scale compute environments that behave erratically at times as well because of the apps that are running on top of it. So we get flash floods, we get incast problems, we get all sorts of interesting traffic phenomena that we often have no visibility to at times. So we have the forwarding plane that if we can build a forwarding plane that is fairly static and, as Martine said, not very complex, then we can actually look at the control plane trying to manage some of this stuff. And the thing that I think we haven't really touched on is the northbound out of this, the more of the orchestration layer of how does the app see it. So today, if you look at the interaction between the network and the app, is essentially an app puts the packet on the NIC and hope it gets to the other end. That's the relief protocol. We just put it on the NIC and just hope it gets on the other end. And in our environment, we are very interested in getting that packet to the other end and knowing that it actually got there, because that's, in the end, that's what user experience is about. So how do we patch that together? How do we build that? How do we know that it actually happened? And then layer on security and things of that nature on top. It is something that is fairly complex, but we need to be able to actually do it in software and not have a very distributed system that exists today, where even doing simple things like we talk about security, and everybody has ACLs at the edge of the network, and how many network operators are scared to death of their ACLs because they don't quite really know they're configured 100% on every edge device. How do you know that? And can we actually have a more guaranteed way of actually enforcing that's actually happening? So a lot of people build tools and things of that nature, but if you could build policy that is admission control and things of that nature in software in a more of a centralized manner, you have a better chance of actually having more dependable or more confidence level in what you actually have configured out there.
Okay. Actually, you brought up the ACLs, ACLs, or access control on the edge and security. When Matt touched on security being a big question mark for a lot of people around SDN, I didn't think to run that by you. How much of a security problem are you encountering as you try to do some of these use cases that you were talking about?
I mean, it's not any different than what we have today, in some sense, right? It's the same security threat profile that we have on any software. The difference is the software is more running in controllers or in server or machine on x86 boxes rather than on network gear. It's still the same. Okay,
great. We're going to go to Q&A in just a second, but one thing I wanted to ask you guys about is so we've established that some of this stuff is already happening, or has already happened, as Martin was saying, and that other pieces are going to take a couple of years to evolve. So if we come back 5 years from now to the same discussion, what kind of discussion are we going to have? What's going to be important? What are we going to be talking about?
Who wants to take it?
Who wants to go?
Go.
Yeah,
very quickly. So, I mean, I think that right now we've got this massive discourse on all of the complexity, and we're having so much fun passing around that complexity, and it's great, and it makes for a lot of conferences, and it makes for a lot of discussion, and a lot of customer dialogue, and it's fantastic. And at some point, that complexity is going to get mastered, and we're going to have simple abstractions, and then the next step, the next phase, the next era, is we're going to actually change the operational paradigm of networking. So right now we're all talking about it because it's cool, and we're building the car, and we're talking about the engine, and we're talking about the wheels, and it's awesome. But at the end of the day, this is really just kind of technical mumbo jumbo that customers don't care about, because we're talking about how you build these systems and supply chain and stuff. But then you're going to build the car, and that's going to change people's lives. And then all of the discussion is, think about compute virtualization. I work at VMware now. So first you're like, wow, all this discussion, dynamic translation and para-virtualization, and all of these architecture battles that people talked about, and then it went away because nobody cares. At the end of the day, you have VMs. VMs are awesome, and they've changed people's lives. And people, we've learned to use these in a way that changed people's lives, right? We can move them across the place, we can expand them, we can shrink them, we can snapshot them, we can rewind them, and it's the laws of physics have changed. I really believe that now, this is great that we have these talks, and it's fantastic we're getting on the same page, and I can't wait till it stops, and we focus on, listen, we've created this new thing, and customers love it, and the laws of physics are different. So I really think that hopefully in 5 years when we come back, we'll all talk about how our lives were changed through not SDN or not through technology, but through the applications it enabled.
Okay, and in a way, we'll be talking about networking in different terms, hopefully. And what are the odds this happens in 5 years?
Well,
real quick, Martin, got a percentage you want to give us?
I think it's happening. I think it's happening now.
It's happening now, but will it be done in 5 years, or will it have happened enough to?
So I will go on record to say that I think in 5 years the conversation is going to move away from complexity, away from the details, away from the mechanism which we've been mired in, and towards the use cases, and we're going to be talking about how it can change people's lives operationally.
Okay, great. Eric, sorry, I cut you off.
Well, I think that's a good Good vision. I think that's going to happen in 5 years. But I think that when we talk about the network and the cloud or whatever data center that's connected today, in 5 years we will talk very much about the network-enabled cloud and the cloud and network coming together. So these compute and storage will move out in the network. You will have software control in this structured layered way that I talk about that goes across all the domains. Because that will actually be the only way to guarantee performance and good user experience for those 5 years, we said. So that's 4 billion smartphones that are out there. When they are connected to these network-enabled cloud services, we're going to talk a lot about what comes on top rather than the exact details of how we did it in the protocol translation at the lowest level. So I think we will have moved away from that.
Yeah. Yeah, Matt, real quick.
Yeah, I've got sort of two pieces to that. One is I agree with Martine that the apps are going to change and that lives are going to be fundamentally transformed. What I think is what we as an industry need to understand is that does that translate into market size and does that translate into market value? And
good questions.
An analogy that I like to use for this is if we think about the adoption curve for SDN, the closest thing to it is server virtualization. And Martine, being from VMware, can maybe help validate my numbers. But if we start to look at the server virtualization market, it took roughly 7 to 8 years for VMware, which had roughly 100% market share, to get to $500 million of revenue on server virtualization. Now, you could argue that networking could be faster because, hey, we all live through server virtualization, so network won't be nearly as bad. That's on one hand. On the other hand, if you look at network refresh cycles, instead of being 2 to 3 years like server hardware, they're 5 to 7. So I think we ought to put this into perspective of absolutely apps are going to change the world and there's going to be really cool stuff like maybe the next Facebook comes out of something like this. But we also have to recognize that for all the rest of us in networking that are building our lives and our livelihoods off of this, that maybe it doesn't necessarily change overnight how we earn our livings and what skill sets we have.
Yeah, and I would add that things, especially on the service provider side, always tend to take longer than you think. So, yeah. Najam, we're just about out of time, but if you got like 30 seconds and you had something.
Well, I think I'll just reinforce the point. To me, this is a paradigm shift, not necessarily building a new app. And today what we're doing is, I think Martin was saying, is if you sat in an interview, if you're just sitting there talking about the data and the data is right or wrong, you're really not figuring out what data is telling you, and that's what we're doing today is we're talking about the data and data is right or wrong, or what does this mean or what does it not mean. We want to be able to get to a point where we're actually thinking about use cases. That's where we're spending time to figure out how do we actually use this technology and what knobs do we need. So we're still working on the mechanics of building something that will allows us to iterate quickly on use cases.
Okay.
And that's where we would like to get to.
Yeah. All right. Okay. Great. I think we'll throw it open to questions now. You guys, well, Patty has the microphone, so by the way, she's the one you have to get the attention.
Neil Swart at Plexi. I have a quick question. Abstractions are going to be very important in the future. I think the big question for you guys on the panel is we can either go at this in a sort of build, measure, learn way of standardizing it by basically trying stuff out, throwing spaghetti at the wall and seeing what sticks, or we're going to be able to try the kind of ITU or ONF way of kind of standardize first and then implement later. From your perspective, looking 2 to 5 years out, what would you prefer to see? Because, there might be one way that's really efficient and capable, and the other might offer a lot of jobs in standardizing it, but what is your take on this?
Any thoughts, guys? Martine?
Yeah, so, hi, Nils. So I think that changing abstractions before you virtualize is really hard because it requires an entire change to people's brains and operational tool chains and everything else. And so I think the lesson that we've learned in systems for a long time is you first want to create something that looks like what you had before. And all the tools still work, and people still know what it is, and people know how to use it, and think it, and debug it. But once you've done that, you've kind of like jacked up the world, right? You've kind of got that ultimate point of indirection. So I think the first thing we're going to do is actually not change abstractions, not introduce new abstractions, so you don't really need to have, argue about what it is. I mean, if what you end up, say we have our magic SDN layer and we sprinkle it out there, and what happens on top of it is you actually still get networking back, except for networking doesn't suck now, right? I mean, it still looks like network, still has L2 service model, L3 service model, acts everything you want, except for you actually have that ultimate point of indirection. And once you have that, now you can bend the laws of physics and you can actually change new abstractions. So I think we actually have a little bit of work to do before we standardize. I actually think we have some work to do, and then we should think about how we should start changing abstractions. Because now I think the adoption hurdle is going to be very, very high. And I think this is some of the friction we're seeing when we're pushing kind of net new solutions into the market.
Okay, yeah, actually I think you got a good point there. We're going to move on to the next one, I think, Patty.
Hi, John Osanich. I'm with Ericsson. I just have a quick question. You guys brought up some really interesting data points. VMware, virtualization, took 7 years to get there. They started with a very definitive problem statement they were trying to solve as well. They were out of room. They couldn't put any servers in, power consumption. There was a whole lot of things that they brought to light there that said, hey, I can solve this problem. If you had to pick one, what's the problem you guys are solving? Because without that, I'm not so sure 7 years is long enough to get to $500 million.
Yeah, well, Najam had one actually, the reiteration or iterating of.
Yeah, for us is very simply the pace of innovation or agility of the network infrastructure is not quite what we need.
What are the rest of you seeing? Because they're depending on how you try to phrase things, there could be 3 or 4 different problem statements that people are trying to attack with SDN. I mean, do we have the foundation to say that there's a certain problem that's going to be attacked that will provide the motivation to make this actually happen? I think Martine thinks there is.
Yeah.
Making networks not suck.
Well, I think compute virtualization is embarrassing the rest of infrastructure. So
Yeah.
I think the general thing is like time to provisioning, operational overhead drops, you get horizontal integration.
And that is the one that I keep hearing too. The fact that with compute virtualization, everything else about the data center of the cloud works so fast, and the network just goes so slowly.
I'd add to that a second one, which is what we see from a number of folks is that it's not just that is the number one driver, but followed close behind is a second driver, which is today, because of the way the network operates and is configured, I have 3 to 5x the amount of compute power in my data center than what I actually use. And that's because they have to segregate their data. Again, this is an enterprise or a service provider that has to have multi-tenancy, but it's hardware multi-tenancy. But how to drive that and how to collapse spend, that also drives back to the automation and the other piece. But there is a cost element to this, but it's not a networking cost.
Okay, interesting. Yeah. Had you?
Hi, this question is for the Facebook guy. What is it that you're... Sorry, Najam. Sorry.
Najam, I'll give you a new name badge with the Facebook guy. We can call that.
The question is, are you looking for more hooks in L2, L3? Is that what you're looking for? Is there something else you're looking for? Can you be a little more specific? And what, besides, we've already talked about virtualization to death, but what else besides virtualization are you looking for? So, one, we don't care about L2. L2 is dead. Long live L2. So we don't want to go there at all. The thing that we're really looking for is, for us, it starts with better visibility on what's actually happening, better control in terms of being able to manage our configurations. So if you think about how we configure things today is engineers sit down and think about configs per element and go try to build a network based on that configuration set. So how do we build a network that we have a specific topology in mind and then the elements just get populated? Right? So what we're looking for in the network space is the ability to have a forwarding plane that essentially just forwards, and then we have a, if you will, a table that we can program on how things are forwarded. Then you can actually look at the application and see how things are flowing, and if you have a feedback mechanism of understanding how the forwarding plane is working, then you can adjust on the fly and be able to manage your infrastructure. Right? I'm just giving you just one use case of that environment. What it translates into into actual in terms of technology. We're starting with a very simple even that the existing platforms we have, can we get APIs? Can we get access directly to run code on those boxes, right? Things like we still get stats out of the boxes through SNMP. SNMP is dead. Again, it's been long dead. It doesn't really scale. It gives us metrics that are pretty useless to us. Can we actually look at the chipset directly and say, what is the queue depth of every VOQ in the box? And based on that, say, this particular port's not happy, what do we do about this? And instead of actually having to poll hundreds of thousands of machines we can have agents running on the machine itself that aggregate that data and push it up to a system that can actually react to it. Right? So that's the kind of sort of environment we're looking for.
Okay, great. Next question.
Hi, I'm Vanessa Alvarez. Matthew, I'm sure that in some of your clients, they're still in the process of just transitioning to the concept of SDN. In fact, I'm pretty sure a lot of their network is still physical. In the emergence of Hyper-V coming into a lot of environments today, in addition to VMware, add that to the physical network, how do customers really manage that environment today when you have both physical and virtual, and now you're trying to lead them down the road of software-defined data center?
That's a good question that I would say we have yet to find a customer that has fully answered that. But what we see is that there are abstraction layers being created, but they weren't SDN abstraction layers. They started with orchestration software, like a product like Service Mesh. I'm not affiliated, I don't have any bias to them. But they're orchestrating the rest of the environment, and now it's about how do you build hooks into things like that to orchestrate both the physical network, the virtual network, as well as other virtual appliances that may insert services into those streams.
They see it together?
They can see it together. Or they're starting to.
And provision and configure and manage?
Absolutely.
Okay, next.
Hi there. This is a question for Martine. You mentioned server virtualization and SDN in the same paragraph, I think. What is your view and the VMware view of that environment? Is server virtualization and SDN about to become part of the same network that doesn't suck, or?
Yeah, so I'm not sure that VMware has an official view on this. Let me just talk as me as an employee of VMware with a personal view. So I think SDN actually had a contribution at some point in time. I think network virtualization is totally orthogonal. So network virtualization is trying to solve a customer pain point. It's pretty much saying you bought server virtualization and it's embarrassing the rest of your infrastructure, so let's make the network have the same operational model, the same supply model, the same provisioning model as the server does. So that's something that customer sees, you can quickly, easily articulate to them, right? Now, there's a second question, which is, do you or do you not use SDN to build that? Now, in my opinion, you use principles from SDN to build that, and it makes it easier to build it. But these are orthogonal things. SDN to me is the engine under the car, which I'm less and less interested in. And network virtualization is, to me, something that solves customer pain point, which I'm more and more interested in. But this is just me talking, honestly.
Okay, next question.
Hi, my name's Doug Tom. I'm with Comcast Silicon Valley. I guess what I wanted to know is how SDN changes programming. Are there languages and other technologies that developers need to know in order to maximize this? Are we still going to be writing C programs that use accept, bind, and listen? What's the story? What's next for developers?
You look anxious to take that one.
I just think it's an awesome question.
Go for it.
I'll visit very quickly. So. In my experience, it doesn't change anything other than you can actually use better distributed coordination primitives. Meaning, you can go buy a vendor box today, you can write in Python, or you can write in whatever you want, and it's the same thing as if you do SDN, the same type of complexity. In both cases, you're aggregating the entire topology and then managing it locally. So it does nothing other than give you a better environment than maybe an embedded environment. But like if you think from a programmer standpoint, it doesn't change your paradigm, it doesn't really change your tool chain. The only thing it does is as soon as you get away from a fully distributed program programming model, you can actually start to use sensible distributed programming practices like Zookeeper or Cassandra or these higher level things that you could never scale if you were doing it by trying to run it in each one of these devices. So so same languages, use whatever language you want. Actually same algorithmic complexity, but you can actually use tools that allow you to do distributed programming in a way that isn't just protocols.
I think the bigger change is not for the programmers, it's for the network engineers who are used to using CLIs and protocols to make things work. And now they have to think about RESTful APIs and things of that nature and be able to program. So 5 years from now, I bet every network engineer will be a software engineer too.
Yeah. Okay, next question.
Rick Pearson, JT Global. My question is from the carrier, from the perspective of service provider and carrier. Erik, you've said numerous times tonight that in the next 5 years we're going to have 3-4 billion smartphones connected to the network. I see some of my carrier colleagues in the audience tonight. We're going to spend over $1 trillion in the next 5 years dealing with data ARPU and getting the bandwidth to deal with this. And now we're being asked to turn control to software developers of our network over, which I understand, but how are your chats going with my world, the carrier world, about this, given the fact that we're so occupied over the next 5 years with building the data capacity to deal with this?
Yeah, I'm sure there are other views on this, and I tried to sort of cover it a little bit in the past, that I don't see this happening in any way uniformly in wide area networks or service provider networks. So this is sort of leading customers in leading markets, and we are fortunate to work with them around the world that are trying it out as a way to perhaps gain efficiency gain, connecting enterprise users in a more flexible way. So they want certain pieces of, if you like, what we term the service provider SDN toolbox. Or this service chaining or traffic engineering case that can be tried out soon without changing the whole network. If it's used in that way, then it is a tool actually to get more revenues rather than only focus on the cost side. But of course the same tools can be used to increase efficiency and gain that advantage as well. So, and I'm not sure that everyone is sort of preoccupied with only keeping up with the data growth, because what's really happening is smartphones coming on with a complete new usage pattern when it comes to both data and signaling and the number of devices and all that. And that is a situation that partly is handled already in the mobile networks. And we're now taking those learning into, again, this SDN world for the rest of the network. So I think we will benefit from what we're doing on the mobile side even more going forward into the rest of the network, even into the data center, even into the cloudified infrastructure. So it's not happening wide sort of big scale. I'm not claiming that, but I'm seeing interest from leading providers around the world to try out pieces of it.
Okay. Thanks. Great point. Next question.
Cesar Orozco, I'm with NetApp. First of all, thanks guys for being here tonight. This is great. I appreciate it. I'm an IT practitioner. I've been in IT for a long time. What can CIOs do today? I mean, CIOs looking for an edge, looking to be more competitive. What can they do today in adopting SDN? And is there a right way to do it? What would be a practical suggestions, recommendation you can provide to those guys? Thank you.
My advice is twofold. One is find a way to find a business champion who will release some budget to do a POC. And that is so you can start to learn where you can innovate and where you can't innovate, and manage expectations internally to be successful. I think second is once you've learned that, and maybe that's 3 months for you, or maybe it's 12 months, then go back to the business and start to say, hey, here's how we can enable you to do something new, or here's where we could give you, a 10x cost savings. It needs to be something along those lines. But I would say the number one thing is start getting the technology in, get a POC running, and start getting the learnings so that you can say, here's how we create business value for the business.
Okay, next question.
Thanks. My name is Ted Weatherford with Marvell Semiconductor, and I'm stuck with whatever the hardware ramifications of all this wonderful problem is. So it's a really exciting time for us and everybody doing what we do. And I'm from the switch group and the ARM processor group, so I'm worried about how this all works. And so what I'm worried about, and I want to just, if you have any comments, is there's an efficiency we're all after, and flexibility to me has a tax. So when I make things flexible for you at the hardware transistor level, we pay for it, right? And I'm just wondering, on your side, is the amount of switching going on compared to compute, such a small ratio that you don't mind that the overall power goes up to give you the kind of flexibility that you need in the layer 3 and the layer 2 forwarding plane of these giant 10 gig, 40 gig, 100 gig switch chips that we all race to get you. Efficiency, programmability, tax, any thoughts on that for us lowly component suppliers? Thank you.
So can I just very quickly? So I think you're ascribing to a definition of SDN that not everybody else ascribes to, which is, my ideal world, every physical network is an L3 fabric. We know how to do LPM. We've been doing it for a long time. There's way less gates than there are today. Hell, we don't even have ACL tables. That's it. No L2, just L3, and that's it. To me, the networking problem is the same thing as a switch port problem in the 50s. You had a box, you had a whole bunch of ports, a packet goes in one, it pops out another. Some function f of x that packets go into and packets pop out of. That, to me, is the networking problem. The intelligence problem, the operations problem, is a software problem I actually think is probably going to be done at the edge and is probably not your concern. So I think this dystopian future you're worried about is almost certainly not going to happen. At least I hope it doesn't.
Good. All right, next question.
Hi, this is a question for Erik. Hi, Erik. Joe Maitland from GigOhm. So I'm curious to just ask you, thinking a little bit about history, on the business relationships between the carriers and how their adoption of SDN might be a barrier. So I remember going back like 10 years, and there was this huge kind of wave with Cisco buying Arrow Point and content-aware switching, and it was this fabulous technology, and it went nowhere. I think they spent $1 billion plus buying Arrow Point, and lots of people spent billions buying these content-aware switches. The thing that stopped it was the carriers didn't want to, it wasn't in their interest to move the content around between each other. My gold service was different to AT&T's platinum service, etc. Is that potentially a barrier here for the carriers in the SDN space?
Well, I don't know, because I think that the way it has started out as a toolbox in the wide area network, it's still on a per service provider, so per operator basis. And I think both the efficiency gain and the flexibility gain, they can be held, or you can get them inside your own network. I think there is a very important point that you're making, that some of these things will probably in the end require some interoperability, at least to reach a global scale, and there may be things that have to be able to move around not only within the network. So you have virtualization not only within your network but across networks. And then of course I would say that's an unsolved issue. So
and that's a business challenge.
That's very much a business challenge. So I don't see that SDN or what we're working today with service provider SDN addresses that. So that is a good point. Thanks.
Okay, next question.
Abhi Singh, I work for HP, and I just, as going through this discussion, it takes me back to the years when I first opened my computer, and I got beaten up for doing so because I broke it. Since then, I've seen the same type of components in all these devices, be it a security device, a load balancer, be it a Cisco router. Basically, everything has the same hardware components, and the software is what is making the packet switch. So really, software is defining the network all this time, but now there is this new term. As somebody who's been in networking all my life, now I need to learn a new acronym that was really doing all this time. But one thing that I saw personally that I didn't hear a lot about today was I had to learn so many different protocols for these devices to talk to each other. And it was almost if network devices were people, somebody was speaking Arabic, somebody was speaking in English, somebody speaking Spanish. And all of a sudden, when I learned about OpenFlow and I learned about these rules and actions, well, there was this common language where there is a rule, and based on that rule, there's an action applied on this packet. So regardless of whether there is a virtualization layer sitting on top of it or not, at least I'm really happy that if there is some standard established for these, even if this is termed specialized computers, that marketing people made for us, which are now called load balancer, security, and routing devices, really everything computers. At least today we have a common language that everybody can talk to, and based on those rules, switch packets, right? So what do you guys think about this common language platform, regardless of this virtualization layer that may or may not exist for these devices to talk?
Are you asking, do we need a common language platform?
We already, based on this open flow architecture, we now have this common language. Do we really need a virtualization layer when all these can now talk the same language? Does that in itself has any merit to it?
I mean, I think those are kind of orthogonal concepts, right? One, I mean, OpenFlow says, okay, so very quickly. So hardware has actually been pretty fixed. So it says, like, if I want a new function out of a new forwarding function, I've got to respin an ASIC, and people are like, oh, that takes too long. So instead, we're going to do more of a RISC type approach. That's what the origin of OpenFlow was, right? So the origin of OpenFlow is we're going to try and do a risky, like a more kind of set of primitives. So when we evolve forwarding functions, we can do it in software. That's why we created it. Okay, so that's one thing. The virtualization that we're talking about is totally independent. So the network virtualization says there's a bunch of operational state today that is being managed by humans, and humans are horrible at distributed state management, right? We're error prone, and we're old, and we get hungover and whatever, right? So these are totally different problems. So people solving the network virtualization problem, you're trying to like automate distributed state management, not talk to switches.
Virtualization is almost a use case. That's how you want to think about it.
Yeah,
it's a use case. Like, we don't use much virtualization because we don't even do server virtualization. Right? So we have hundreds of thousands of machines, and we really don't do virtualization. Yeah. So virtualization is not a use case for us.
Yeah.
But we are very interested in SDN.
Okay, next question.
Hi, I'm Kelly Wanzer from Stateless Networks, and when I saw their panel tonight, I was really excited to hear Najam talk about Facebook's implementation of SDN and tell us how it went. And it sounds like maybe you're still at the front end, if I'm understanding correctly. If not, I'd love to hear about your implementation, deployment experience, and what you can tell us.
We're just starting out. I wouldn't say by any means that we're using it in wide scale. We have a bunch of POCs going. We're looking at use cases and developing that more prototype stage in that sense.
So my question evolved to the panel, which is, are there any of you that can tell us an example or a use case story of SDN, live in production in its current manifestation, being used successfully, and what we can learn from that? Are we still all in the proof of concept phase? Are there any interesting tales we can tell?
I think Martin was arguing that stuff has happened over the past year already.
Yeah, sure.
We have
deployments. I mean, we launched with, when Nicira launched, which was almost a year ago now, we launched with 5 companies we decided to launch with. One of them, for example, was Rackspace. Got tons of VMs under deployment, central controller managing it. I mean, it's SDN in every sense that certainly I'm aware of it.
And how did it go? Was it easy?
Still going.
Still going. Haven't run around a business yet.
Yeah.
Haven't destroyed them yet. Okay. I think we have time for 2 more questions. Quick.
Craig, my question is for you, Don McCullough, Ericsson.
I'm not the one who knows anything up here.
Well, you've been writing about it you've been writing about technology for 10 years.
There's a difference.
And I would ask you where SDN is in the hype cycle compared to other technologies, and what you think, where you think that hype cycle will take us. We've talked about, production and technology, but from a media point of view, where do you think it is?
Yeah, I think it's pretty high in the hype cycle. Way up there, yeah. We're at the point where people are asking about startups getting acquired and when the new startups will be formed so they can get acquired. And every time that happens, something bad happens. The difference, I think, is that SDN is real. It's going to get to a point where we don't talk about it in such glorified terms. Yeah. Next question? Last question.
All right, so I guess I'm asking the last question for the panel tonight. How do you see the role of applications in an SDN world, and what's going to be the impact of applications on a software-defined network, or vice versa? Can the network define the applications? And if I'm a user, how can I benefit from something like an SDN? Thank you. Actually, I have an answer for the last question, but...
Yeah, well, I think applications on different levels. I'm sure there will be others having other views of this, but what we see when it comes to connecting network applications, be it all the ones that are regular ones, the DPIs, the firewalls, and all of the caches and other things, then SDN and the use case that I think I've talked about a few times now with traffic engineering or service chaining is actually tying together those applications in a simpler way. So you can save costs, but you can also get more flexibility out of those applications. Then when it comes to higher up, then we get back to the discussion about need of further abstraction and getting application developers to use them. That's a whole different thing, and then I don't think that, as we said, SDN solves that. That needs another layer of exposure at the highest level.
Okay, great. I think that wraps that part up. Please stay seated. We're going to bring Karen back up for some closing remarks.
Great. Well, I would like to, on behalf of our audience, Churchill Club, thank all of you very much for sharing your perspectives so honestly and candidly. We really appreciate it. And Craig for doing such a wonderful job leading the discussion. Thank you. And as a very small token, but sincere token of our appreciation, we present you with this Churchill Club speaker T-shirt.
Hey.
Please wear it in good health. Thank you again to Ericsson for hosting us tonight, and thank you. You've been a wonderful audience. See you next time.
Yeah, thank you.